Hi, welcome to my inaugural video on my YouTube channel. I've got some videos here from my talks and conferences I've done, but I want to start creating some original content for my channel, starting with this pre-recorded video, just kind of a rough run through before we do some live stuff. I've got OBS set up, I've got the background music, I've got the current track playing with the album art. I think this is going to be good. If you know my friend Martin Wimpress, aka Wimpy, this is going to be a very bad approximation of what he does. That guy is good, but I am learning from the master, and let's see what I can do here. So today we are going to install RISC OS on a Raspberry Pi 400. So what does all that mean? So first, the Pi 400. So I have a Pi 400 here, right here. You see it is an all-in-one. There is a Raspberry Pi 4 based SBC in here. This came out after the Raspberry Pi 4. The fun story behind this is that we were launch partners at Canonical for the Pi 400. So we might have had early access to the hardware, and it was certainly exciting to see kind of the rumors about this device get out there, not from us, of course. And then when it did launch, we were part of that, and Ubuntu had first-class support for the Pi 400. This one right now is running Raspbian, based on Debian Buster. You'll see plugged into the back here, we have some ports. We have a micro HDMI. We have a USB-C power supply, the mouse, and a Ethernet cube. So that's what's running in there. Otherwise, inside it is a Pi 4 that's been slightly modified. There's a heatsink in there. Performance-wise, it's pretty good. Comparable to the Pi 4. So, what is RISC OS? Good question. So, a little history here. Let me show this here. So, we know ARM today, and ARM makes the reference designs for the chips used by Snapdragon, Apple M1, chips by MediaTek and Broadcom. Basically any mobile device, most mobile devices, a lot of embedded devices. They've been ARM actually for a long time. And ARM is a subsidiary of what was at one time called Acorn Computers. If you're not familiar with UK, PC history, Acorn was basically the Apple of the UK. So if you went to school in the US, and you're roughly my age, you probably had Apple IIs. Cheap, durable, relatively cheap speaking. I mean, they were $2,500, $5,000 adjusted for inflation, or more. By comparison, but compared to the mainframes at the time, they were inexpensive. PCs meant for the home and education market, and that's where Acorn thrived in the UK for a long time. And it came to a certain point where they were evaluating which processors to go with. Motorola was cooking up the 68K. Intel had x86, and Acorn looked around and decided, let's just make our own chips. Let's design them ourselves. Sound familiar? AKA Apple. And that's not supposed to go to sleep, but it did. So this is going to be a rough cut. I'm not editing this video. We're going to learn this whole process together, rough edges and all. So Acorn developed an operating system to run on its devices, including eventually a GUI desktop OS called RISC OS. Now, if you're not familiar, RISC stands for Reduced Instruction Set Computing. And these processors, reduced instruction set, literally minimized the instructions that the CPU is capable of running. This made them more power efficient, made them more durable. Sound familiar when it comes to what ended up in our mobile devices? That contrasts with RISC, which is complex instruction set computing, which is more of your x86. Those tend to be more power hungry. If you've ever written x86 assembly versus ARM assembly, if that's something you are masochistic and want to do, you can pick up on the differences there. The legacy x86 instruction set is just massive. Whereas what you get with ARM and RISC is much more simplified. And Acorn then set out to build their own chips, and they did for multiple devices, including workstations, set-top boxes, education market devices, and more. Eventually, though, Acorn didn't quite make it, and pieces were sold off over time. What we now know as ARM was their computing device subsidiary. And they now create the reference designs used for all these chips, including the Pi 400. And eventually, the operating system that they developed, RISC OS, was open sourced and is available for download. And it's available for download for multiple hardware platforms, actually. There are several, BeagleBoard, PandaBoard. We are most interested, of course, in the Raspberry Pi. So I'm not super familiar with RISC OS. I do know RISC OS was developed, late 80s, early 90s. It's strongly influenced by the design paradigms at the time, especially coming from Unix, like one-click to run applications. But it has its own unique taskbar. It has its own unique, window decorations and interface. I have not spent much time in there, but that's why I'm doing this, is because I want to check it out. So you can download images of RISC OS specifically for the Pi 400, and we're going to flash that to a micro SD card. I kind of want to say burn, just from CDR days, but that would be dating myself. So we're going to grab a RISC OS Pi 400 image, and we are going to flash it to an SD card and boot up Pi 400 and see what it's like and poke around. So what I have now booted on the Pi 400 is Raspbian 10 based on Buster. It is running here on a different SD card. We're going to pop that one out and then pop in a fresh SD card. Here is my conundrum. I don't have a SD card reader by itself. I just don't have it. I've got a whole box full of cables and adapters. No micro SD reader. But I do have a ROC Pro 64, which is a ARM-based SBC. It's up there. It's behind that ThinkPad. And I boot that from a eMMC module, which is on the board. It's extra. If you go for the ROC Pro 64 to get the performance, I highly recommend spending the extra $10, $15 to get the eMMC. So that you're not bottlenecked by the SD card. But that means we have a spare SD card slot available that we can use. So what we're going to do is we're actually going to SSH in to the ROC Pro. We're going to grab the URL, download it, flash it with, unzip it, flash it with DD, and then swap the SD cards and take a look at RISC OS. First, let's grab the URL. For the Pi 400, it is here. We're going to right click, copy that link. I am going to pull up my Windows terminal. I'm already SSH in. I'm going to download that URL. So I'm using ARIA. If you're familiar with wget, ARIA is a drop-in replacement for wget, except it is multi-threaded. It will resolve complicated URLs a little bit easier. Like, it doesn't just give up. It'll parse them. It handles magnet links. It handles torrent files. It is dramatically better performance-wise over just plain wget or curl. That is going to take quite some time, it looks like. Longer than I expected. Interesting. No. Okay, now, okay, in the meantime, I can just talk while we wait. And those of you who might know me, if you're following my YouTube channel, you might be following my Twitter. I am a big fan of obscure operating systems. You probably see my Unix poster. I like playing with old operating systems, obscure operating systems, running them in virtualization. It's kind of where I got my start with virtualization that led to WSL and now Windows on Kubernetes. And, you know, my favorite operating systems include things like BOS. BOS was a operating system that was originally developed by a team from Apple that left Apple and created their own device called bBox. It was based on the Motorola 68K. It was later ported to the Mac, and you could run it up until the PowerPC G3. I believe Apple locked out the clones and third parties from the G4s and above. So that's when BOS pivoted to x86, and you could get BOS 4, maybe 4.5 for x86. What was crazy about BOS at the time is that when other operating systems, like Windows, would take, you know, a good 5-10 minutes to boot, bBox would boot in seconds. It was just phenomenal. It was written in, while every other operating system was, you know, still 16, 32-bit, it was 64-bit, preemptive multitasking, hyper-threading. You know, it was the only operating system that at the time where you could have a browser, you know, Real Player and Quake all running at the same time. I mean, that just, you know, it blew everyone's mind. On like a Pentium 2 with 16 megabytes of RAM. It had its own word processor and Office suite. It had, you know, it had Firefox, Opera. It's just never completely made it into the mainstream, and eventually folded. All right, that zip is done. We're going to unzip that here. And, you know, the funny thing is that when Apple was deciding where to go, you know, System 9 was just bad. Like, it had so much legacy debt and issues. They knew they needed a new operating system. They looked at either acquiring Next and getting Next Step, which is what they ended up doing, because they also got Steve Jobs back in the process. But they also looked at BOS, and BOS would have been an interesting option. It now lives on as Haiku, an open source rewrite. Also very fast. I think they're approaching a beta, if they're not in their first or second beta at this point. What I like about Haiku is that it is nominally POSIX compatible. It's got your full GCC GNU developer toolchain, and Qt 5 is imported. So anything that can be built with GCC and Qt 5, including GUI apps, can run on Haiku. That includes LibreOffice, KDE, distro apps. Its app gap is catching up. It's still, though, mostly a hobbyist OS, but it does now have a full-time developer working on it, which is fun. RISC OS, of course, is a little bit older. It was developed for PCs in the 80s and 90s. So, of course, it just screams on modern ARM chipsets. So even before that, the applications there were super light and really close to the metal. I think a lot of them are written in assembly. I know C and C++ is available for RISC OS, but I think a lot of the apps are still just written in assembly. So we've got that image right there unpacked. We are going to DD it to the SD card slot over there in the Rock Pro. That SD card slot is a 120 gig SSD plugged in at MMC block 1. So we're going to sudo dd input file, rl output file equals dev MMC block 1. We're going to set the byte size to be 2048. Shouldn't give us any problems. We're going to give status equals progress. If you're running a recent version of DD, you've got that status equals progress option. That is super nice, so you're not just staring at a blinking cursor wondering when your image will eventually be copied over. All right, so that's going to unpack to be about 2 gigs unpacked. So a few things I know about RISC OS. I have not played with it nearly as much as Haiku. I mean, just a few minutes here and there. I know the applications are one click to run. That was a common trend in Unix at the time. They have its own taskbar. It's a very unique operating system unto itself with its own UI, UX paradigm that is separate from Windows, from Linux, and from Mac OS at the time. That's what makes it so interesting. Even BOS had some, Unix-like design that made it feel familiar and had a, cascading button that listed your applications hierarchically in folders, not like the start menu on Windows. But RISC OS is unto itself. But yeah, I like these different operating systems. I love that you can run the RISC OS on modern Pi hardware. Of course, Pi is not associated, the Raspberry Pi Foundation isn't associated with ARM in any way, but it's just one of the platforms that the RISC OS project targets. And there are a few derivative distros too of RISC OS. You can get some RISC OS derivatives that come prepackaged with different applications and that kind of thing that I've seen. So those are out there. And yeah. You'll see what I have running behind me. I've got my Rock Pro 64. That's kind of just a standalone SBC I keep. It runs file server, it runs Plex. I use it for just utilitarian purposes. It has USB 3. It even has a PCI slot. So if there's an old PCI card, if I need to throw a Wi-Fi card in there. It has Wi-Fi. I have the Wi-Fi chip plugged in. But if I need a second Wi-Fi to build a bridge of some kind, that's what my Rock Pro 64 is basically there for. Back there, I also have, by the way, it runs Armbian, which is a focal-based distro. Unfortunately, the distros available for the Rock Pro 64 just aren't as diverse and stable as what's available for the Pi, even though it's much more powerful than the Pi 4. For example, the OpenSUSE tumbleweed image, the GOS, the GEOS, just enough operating system image, doesn't support booting off the eMMC chip, only the SD chip, and has some boot issues with the kernel. But Armbian works great. There's some Arch. You can run Chromium on it as well, even Android. But just for stability's sake, I would be on that. The ThinkPad T470S back there runs OpenSUSE Tumbleweed. That's my main virtualization device. It's got like a 6th gen Intel in it, but it's got 20 plus gigs of RAM. And it's just a headless station for running all kinds of VMs. I've got the Pi 400, which is fun for projects. I think after this, I've got a retro gaming project I want to use it for. And then my main rig here is a Lenovo Legion T730. So at a certain point, the only way to get a graphics card was to buy pre-built. And I'm a big fan of Lenovo devices. I like that I can get the warranty and get the on-site service, usually next day. That's even better than what Apple can provide. So I went with the Legion T730. Would I prefer to ThinkStation, T700 series? Probably. But it's what was available, and had the 2070 in there that I wanted to run Flight Simulator. All right, that is unpacked. So I am going to go grab that real quick from that from the Rock Pro. Back in my squeaky chair. So first we're going to shut down the Pi 400. Go. Right. We're going to pop out that micro SD card. Always make a note of the orientation because there's like 4 ways to put these in. Pop in the new SD card. I'm going to bring up that HDMI output. Go back in. Let's see what happens. Oh, saw the bootloader. Okay, here we go. RISC OS, Raspberry Pi. Yeah, they even make clear here that the RISC OS is not affiliated with the Pi Foundation. RISC OS is available for multiple chipsets, actually. It was just originally developed from the parent company that also created the ARM chipsets. That is booted. Let's go do some exploring. What we look like here is a browser. I've got Ethernet running. I wonder what kind of performance we've got here. Oh, so Control A selects all. So we've got some pretty familiar shortcuts, keyboard shortcuts that work. And we've got a browser that works. Fascinating. All right. Let's see what's down here. We've got a Raspberry Pi. Okay, so we've got a task manager. NetSurf is only using. Let's see. Okay, so yeah, quite a bit of free memory here. Yeah, this has 4 gigs. Looks like most of that is free. So yeah, this goes back to RISC OS being super close to the metal, super optimized, from those original ARM chipsets being super simple, inexpensive, durable. And what that evolved to was the durable, power efficient, optimized chips for mobile devices. You know, Intel tried to make x86 happen for mobile, and they were hot. They just couldn't do it. It's really the result of that RISC architecture that enabled, and this legacy of small, inexpensive, durable chips, plus the RISC chipset that makes ARM what it is today. Of course, now you get the ARM chip, and then you build a system on a chip, and you add in a GPU and an AI accelerator and all kinds of things to supplement that main processor. But let's see what this is. Let's see if we can change the resolution here. Make it something. Okay, it's a little stretched. But that might be more visible for the video. Try this. 20. That's more comfortable. All right, hopefully you can see better now. So we have a browser called NetPlan. That's pretty cool. It works. Let's see if it loads. Yeah, it doesn't look like it's loading modern web pages, but still. Oh, we lost some. Board. Interesting. So by changing resolutions, we lost some stuff up here. Let's see if we can bring it back down. Huh. iStore. Let's see what the iStore is. There's catalog. There's that British influence right there. The British spelling of catalog. Looks like there is an app store here for RISC OS with paid apps. Interesting. All right, Snap. All right, Flatpak. Where are your paid stores? If RISC OS can do it. Interesting. See what else we have here. Apps. Edit. Probably your text editor. Okay, so this seems to be. Huh. You know, that actually looks a lot like BOS, especially with the yellow. Just saying. I'm not saying there's any. I'm not aware of any design influences at the time. They're just around the same time, I think, in terms of the evolution of operating system design. Pac-Man, this looks interesting. Would you like to update? Yes. So it looks like in addition to the store, there's their general package manager. Well, let's see what we have to upgrade. There's a screen capture utility, a backup, 5 megabytes. Huh. Let's update it. Let's see how much. Right, so NetSurf is still running. So this is the taskbar of some kind, and this must be the launcher. Wow, even that package manager, while it's updating, is barely using 5 megabytes of RAM, and then NetSurf is barely using 8 megabytes. Of course, it's not rendering the JavaScript as well, but it's there. Looks like it's got 5 megabytes set aside for their operating system. Well, look, free. So those of you who really hate when your applications use your RAM, you got 32 gigs, but it's got to be free all the time. Don't let any Electron apps use any of that RAM that you've paid for. RISC OS might be a viable option for you. I kid. All right, done. Close. All right. Interesting. Let's see what we've got here. Is this, you think this full screens? Yep, there we go. Okay, we've got basic, bash. Okay, so there's some basic, there's some basic GNU and basic tools here. BC, okay, Bison. So it looks like there's a fairly, the beginning, bzip. So some common POSIX tools. Wow, that is fast. All right, let's get bash while we're at it. Let's see what happened. We've also got that. A clipboard tool, of course, every OS. You get GNU Core Utils. BitTorrent client, you're going to need one of those. You get support for audio, FFmpeg, Firefox? No. There's a caution next to that. That's really surprising. If that's Firefox 2, that's ancient. Is it really Firefox 2? If so, it would be... it would be unsafe to use. Okay, GCC 4. It's not bad. Huh. DOSBox. Alright, so you can run your Microsoft DOS and your DOS games on your ARM computer. Your Pi 400. This will probably be a bit larger. Yeah, see here you see references to BBC Basic, and this is where it goes back to Acorn being part of the education market in the UK. Acorn developed these education devices. They also developed set-top boxes that for televisions that provided like on-demand news and sports, stock, similar in a lot of ways to like early Prodigy and CompuServe in the US. The French had a similar system where you could buy a simplified computer that operated basically over TV, alternative to dial-up. I'm not quite sure exactly what the French system used, but you saw this in Europe, where the state telcos kind of saw what was happening with Prodigy and CompuServe and equivalents in the US and offered their own. Well, Acorn was part of that in the UK, and there were Acorn devices that plugged into the TV, and they provided like a curriculum. There was a curriculum available for learning BASIC, and there was BBC Basic. You could learn. All right. Still skeptical of that Firefox. Hexen and Heretic. That's fun. So if you played Doom or Quake or other games from ID, Heretic was among them. And the funny thing about Heretic is that if you tried to use Doom cheat codes, it killed you automatically. You just died. So looks like there's alternative application launcher, libs like Bison, curl. So it looks like you could do a fair bit of porting here from another POSIX environment like Linux or BSD, as long as you don't get super complicated. P7-zip or 7-zip files, Perl. Of course, this would be the heyday of Perl. Python 3.8, not bad. And it looks like they have Qt5 support here too, including Qt5 WebKit, which, if it's up to date, would be a modern web browser. Here we go. Exactly. Let's install a modern web browser. RISC. Yeah, I bet you it's going to bring in a lot. This is going to take a minute. In the meantime, let's go see if some of the other stuff we've installed has showed up. Open it. I don't know where. Oh, here's DOSBox. I don't know where BASIC went. I don't know where there's a terminal. Maestro. Text editor. What do we do? Land manager. Okay, well that's fun. Let's run DOSBox. Yep, there it is. Oh. It's probably running their built-in version of FreeDOS, or does DOSBox bundle its own DOS now? Oh, worth looking into. That's fun. Okay. Just wish I knew where my terminal was. Yeah. Here's something. Oh, this has more than this does. I don't know why. We are literally figuring this out as we go. Aha, here's Bash. It looks like all the applications start with a exclamation mark. That seems to be a thing. That must be how they note executables.
Right. But how do I exit application? Do I even need to? Probably not. Let's do this again. It's not working. Let's see what's in Avid. Nothing. No. Nation DOSBox, of course. Miscellaneous. Aha, here's basic. Ah, here we go. I don't think this is going to work right because, yeah, you think, mistake. The character map is broken. And when you're not getting, when I press O, I get a 6. Oh, hang on. Does that mean numlock is on? Did it boot with numlock on by default? I think it did. How do I turn it off? Okay. It's not a character map issue. Numlock is stuck on. Lock off. Show you what I'm doing. Oh, found numlock. And apparently RISC OS boots with numlock enabled. I'm still getting character issues. Need to go brush up on my BBC basic, maybe. I need to see what is that. It's not being quotes, I'm getting ampersands instead. There we go. Here she is. I hope we can get out of this. It is full screen, and I do not know how to. Huh. Wait, an exit does not work. Q, Control C, Control X, Alt Tab. Well, that is unfortunate, but bound to happen. Let's see if we can. Now we're just pressing buttons. Now you're just pressing buttons. Oh, escape tells us escape. All right, so let's do this. Hold down the power button. No. All right. I'm gonna do it. You ready? Let's hope that install
finished the background. But I think this was enough to give you a good overview of RISC OS, some background on ARM and CISC and RISC, and kind of where we got where we are with the ARM chips in our mobile phones, coming from this basically Apple of the UK, creating these efficient, inexpensive designs that later get harnessed by everyone to build mobile devices and IoT, and end up in the Raspberry series, among others. And then get a sense of what the OS, which was originally intended for these devices in the late 80s and early 90s, kind of looked like, and get some experience with a different operating system with kind of a unique paradigm, but actually some surprising modern applications. You've got what looks like most of the GNU toolchain there, Qt 5. It's not quite as far along as Haiku in terms of like having LibreOffice ported or any of those things, but it's pretty far. It reminds me of a little bit of what the folks who are still a fan of Amiga are doing with an OS originally built for the early 90s running modern applications. So I hope you enjoyed this video. I hope you enjoy learning about these obscure operating systems and some personal computing history. If I made a mistake, feel free to argue with me in the comments. I look forward to streaming these live more going forward, having some interaction. Thank you for joining me, and I look forward to speaking with you soon. Please subscribe. Thanks.